For note 2, we get a system of equations. I threw a couple of these in your homework where you look at y equal -2 or x equals some value. On this one where it says y equals -2, that's a special line. That's telling you that every point in the line will have the characteristic that its y value is -2. In other words, when I graph this, I know that it has to be horizontal. Why horizontal? Because that forces every y value to have the same number. Example of what I'm talking about. When I go to graph this, I don't have to worry about any slopes. I just go -1, -2. Every point on this line has a -2 for a y value, which forces it to be a horizontal line. And so I can simply shade this line in here. It should be a quick problem for you because you didn't have to worry about any slope. All you had to do was find a starting point and run horizontally. Y equals are always horizontal. X equals are always vertical. This has a slope of 0. So I'm just going to do this. And I knew I had to be at -2. For the second equation, I gave it to you in slope-intercept form. So you should be easily able to pull out a slope. Slope is 4/5. And the starting point would be 0, -6. Plug 0 in for x. That means that y is -6. And so I start at -6 on the y-axis. 1, 2, 3, 4, 5, 6. Tells me to start here. And I need to follow my slope, which says go up 4 units. 1, 2, 3, 4. Right. 1, 2, 3, 4, 5. Up. 1, 2, 3, 4. Right. 5. So quickly I found the point of intersection. I connect my dots to form the line. And I want to identify my point of intersection. The point of intersection is located here. That would be 1, 2, 3, 4, 5 units over. So that's a +5. And 2 units down, -2. What's special about this point of intersection? It's the only point that will solve both of these equations at the same time. So that's your solution, 5, -2.